Okay, so use substitution. What is it? Simply put, it's a method for finding antiderivative in more complicated functions. So what we're going to try to do is essentially create a substitution so that all of our integral is in terms of u. And once we do that, hopefully we will have, the goal is to have a function that's a little bit easier to do the antiderivative. If you end up with something more complicated, something's not right. So the first thing that you need to realize, we have two functions here. We have a sine and we have the inside of the sine, which is 2x plus 3. Some students might be able to do this in their head without this method, but I'll show you how this works with a simple function. And as you can see, we have more examples that work up in level of complexity. So we start by first picking what will u equal. And in this case, I'm going to let u equal simply 2x plus 3. I have two little rules that I use for picking u. First of all, I pick the function that is in the most complicated position. In this case, 2x plus 3 is inside of sine. And I also like to pick a function whose derivative is located somewhere in the expression. Now, the derivative of 2x is simply 2, and it does not have an x. You notice that there's not an extra x outside. And so that kind of tells me that I picked the right thing. And as I go through the example, you'll see what I mean. The next thing I'm going to do is I'm going to take a differential, because you see we're working with dx here. And I'm going to use that to help me replace dx. And before I do that, I'm going to go ahead and show you what I've got so far. I've got the integral of sine, but instead of 2x plus 3, I have now said that that's u. So simply I have sine of u. But I still have times dx. Now I can't have a u and x, that's not okay. I have to have the same variable. So I have to figure out a way to replace this dx with something that has du. And since dx is a differential, that's why I said earlier we're going to take the differential of u. So if you recall from a while back, if you take a differential, that's simply taking the derivative but also multiplying by dx. So if we take the differential of u, that's simply du. And on the right side, it will be the derivative of the function, in this case 2, times dx. That's how you do a differential. Now you're going to notice here that I have a du, which is good. I'm going to be able to have the same u in sine and in du. But I have this dx, and I also have this dx here. But this dx is not a 2dx, and here I have a 2dx. So I can't exactly just do a straight up substitution, because they're not the same exact thing. So what I'm going to need to do before I can do that substitution is sort of prepare this. I'm going to divide by 2, which is the same as multiplying by a half. And so what will happen is that I now have a dx alone. So I have 1/2 times du equals dx. And that's perfect, because now dx and dx are exactly the same. And what's going to happen next is that I'm going to take this 1/2 du, because it's equal to dx, and it's going to take the place of dx right here. Okay, so I will have now, my new integral will be sine of u, but instead of dx, I will have 1/2 times du. Okay, now this is a property of integrals. So whenever you have multiplication and one of those things is a constant, you're allowed to pull the constant outside of the integral. You are never allowed to pull out a variable. You can't pull out sine, you can't pull out anything that is not a constant. But since 1/2 is being multiplied in this case, it can be pulled out. And I'm going to go ahead and pull it out because it's going to give me something a little bit simpler to work with. So I have sine of u times du. Okay? At this point, I have completed a successful substitution. My x's are gone. My u's have replaced it. Everything I've done is legal. And sine of u is simpler to work with than sine of 2x plus 3. So I'm preparing to take the antiderivative. Because this is an indefinite integral, we simply do the antiderivative plus c. So that'll be, the antiderivative of sine is negative cosine, so that when I take the derivative of cosine, I get negative sine, with an extra negative that gives me positive. Don't forget, you also have a 1/2 to multiply, so I'll squeeze that in here, and it's plus c. So I've now taken successfully the antiderivative, but I have to remember that in the beginning I didn't have u's, I had x's. So right here where this u is, I'm going to go back and say, oh, well, u is 2x plus 3. So I'm just going to replace u with what it originally said for my final answer, which will be negative 1/2 cosine of 2x plus 3. And don't forget, plus c. So I want to go ahead and just kind of repeat. Substitution is a method that allows you to replace x's with u's or t's or whatever the function is using. You're replacing it with u's, but the goal is to create an expression that's easier to find the antiderivative than what you started with. At the end, you replace that u back in, take the u out, put your x's back in, and that's it. So this is one of the more basic examples of U substitution. I'll end this video here, and then I'll create a few others with more examples that go up in the level of complexity that you can watch if you need them.